In the annals of military history, few machines embody the intoxicating allure and ultimate futility of hubris, quite like the Panzerkampfwagen VIII Maus. It was a metal behemoth, a titan conceived in the darkest days of World War II, a testament to a dictator's obsession with ultimate power. For Adolf Hitler, scale was synonymous with invincibility, and the Maus was to be his crowning achievement, a fortress on tracks, an unstoppable engine of destruction that would shatter enemy lines and demoralize the opposition with its sheer, terrifying presence. But what started as a dream of unparalleled might quickly devolved into a logistical nightmare, a monument to engineering excess that became one of Nazi Germany's most spectacular, fatal errors. The story of the Maus begins not on the battlefield, but in the ornate halls of the Reich Chancellery, in the mind of a man who increasingly dictated military design based on his own fervent, often amateurish ideas. On June 8, 1942, Hitler summoned Dr. Ferdinand Porsche, the brilliant automotive engineer, and laid out his vision. A super-heavy tank weighing at least 100 tons, armed with the most powerful cannon available. This wasn't just about tactical advantage, it was about psychological warfare, about creating a mythical beast that would strike terror into the hearts of the enemy. Porsche, ever eager to please the Führer, took up the challenge with characteristic zeal. He immediately began sketching designs, pushing the boundaries of what was technologically feasible. But Hitler's demands didn't stop there. By the end of 1942, the weight target had ballooned from 100 to an astronomical 188 tons. The main armament was to be a monstrous 12.8 centimeter KWK 44L/55 cannon, capable of obliterating any Allied tank from kilometers away, complemented by a coaxial 7.5 cm KWK 44L/36.5 cannon. The armor was to be impenetrable, 220 mm on the turret front, 200 mm on the hull front, and 180 mm on the sides. It was to be a land battleship, impervious to any known anti-tank weapon. This almost childlike fascination with bigger is better blinded Hitler to the practicalities. The generals, more concerned with maneuverability, logistics, and mass production, quietly expressed their skepticism, but Hitler's word was law. He saw not a tank but a symbol. And so the engineering marvel that would become the Maus began its tortured journey from concept to steel. Ferdinand Porsche was a visionary but also an idealist. He approached the Maus project with an almost artistic ambition, seeing it as an ultimate test of German engineering prowess. He tasked his design team with solving unprecedented problems. How do you move 188 tons of steel across soft ground? How do you power such a leviathan? How do you cool an engine that could barely propel it? The initial design, the VK70.01 Porsche Type 205, quickly evolved. The sheer weight necessitated an entirely new approach to the drivetrain. Traditional mechanical transmissions simply couldn't handle the torque. Porsche, known for his innovative electric drives, proposed an unconventional solution, a petrol-electric hybrid system. A Daimler-Benz MB 509 V12 aircraft engine, or later a Daimler-Benz MB 517 diesel engine, would power an electrical generator, which in turn would drive two electric motors, one for each track. This was complex, heavy, and demanded an enormous amount of copper, a critical strategic material Germany was short on. The suspension system was another marvel of over-engineering. Each track was an incredible 1.1 meters wide, comprised of 24 separate link elements, each weighing a staggering 66 kilograms. The entire track assembly alone for one side weighed over 10 tons. To distribute the immense weight, the tank featured a sophisticated torsion bar suspension system with 24 road wheels on each side, arranged in 4 bogies. It was designed to glide over obstacles to crush anything in its path, but the ground pressure, despite the wide tracks, was still immense, comparable to a main battle tank, but for a vehicle 4 times its weight. While the engineers toiled to make the mouse move, a far greater enemy loomed: physics and infrastructure. From the very beginning, even before steel was cut, it was clear to anyone with an understanding of logistics that a tank of this magnitude would be utterly impractical. The most glaring problem was bridges. A typical German road bridge of the era was designed to handle loads of 15 to 20 tons, maybe 30 tons for heavy traffic. The Maus, at 188 tons, was over 10 times that limit. It simply could not cross any existing bridge in Europe without collapsing it. This wasn't a minor oversight, it was a fundamental crippling flaw. The proposed solution was equally fantastical. The Maus would have to ford rivers, and not just shallow streams, but deeper waterways, driving along the riverbed. To achieve this, the tank was designed to be completely watertight, with special snorkels and pumps. 2 Maus tanks would even be able to cross together, one providing power to the other underwater via an electrical cable, while its own engine was shut down. This was an astonishing feat of engineering, but also a logistical absurdity. Imagine the time, resources, and vulnerability involved in moving a Maus across a river this way in the middle of a battle. Every kilometer it moved on land would require colossal effort. Roads would be destroyed, bridges bypassed, and vast amounts of fuel consumed. The idea of deploying multiple Maus tanks was a fantasy. Even one would paralyze an entire transport network. The true cost of this machine wasn't just in steel and man-hours, but in the complete disruption of any operational plan it was part of. The technical reality of the Maus was a direct confrontation with the laws of physics. While Porsche and his team were refining the complex electric transmission, another industrial giant was wrestling with the sheer mass of the vehicle's shell. Krupp, the legendary steel magnate of the Ruhr, was tasked with producing the hull and turret. For Krupp's engineers, the Maus was not just a tank, it was a mobile bunker. The steel plates required for the turret front were so thick that they pushed the limits of contemporary metallurgy. Cooling such massive sections of steel without creating structural flaws or soft spots was an immense challenge. If the armor wasn't perfectly tempered, the impact of a high-velocity Soviet 122mm shell wouldn't just dent it, it would cause the entire plate to shatter like glass through internal stress. As the first hull took shape in late 1943, the sheer scale of the machine began to intimidate even the men building it. It was over 10 meters long and 3.6 meters wide. Standing next to it, a grown man barely reached the top of the tracks. This was the moment when the fatal error of the design became visible to the naked eye. The internal volume, despite the tank's massive exterior, was surprisingly cramped. Most of the hull was occupied by the colossal MB509 engine, the massive generator, and the intricate cooling fans needed to prevent the whole system from melting under its own heat. The weight of the turret alone was 55 tons, more than the weight of an entire Panther tank. To rotate this massive crown, the Maus required a dedicated auxiliary engine just to provide power to the turret motors. It was a mechanical nightmare where every solution created 2 new problems. If the main engine failed, the tank was not just a sitting duck, It was an immovable 188-ton block of steel that no other vehicle in the German inventory could hope to tow. In fact, the German recovery doctrine for the Maus was almost comical. It was calculated that it would take 5 Panther recovery vehicles, linked in tandem, to move a single disabled Maus on level ground. On a slope or in mud, it was effectively impossible. By December 1943, the first prototype, known as V1, was ready for mobility trials. Because the actual turret was still under construction at Krupp, the V1 was fitted with a massive concrete block of equivalent weight to simulate the load. The first time the V1 attempted to move under its own power at the Alket assembly plant, the ground beneath it began to groan. It was here that the logistical horror truly manifested. The Maus didn't just drive on roads, it consumed them. The high ground pressure combined with the shearing force of the massive 1.1 meter wide tracks when turning would strip the asphalt right off the substrate. During the initial tests at Böblingen, the V1 prototype ventured off-road for the first time. Within minutes, the test drivers realized the gravity of their situation. On firm soil, the Maus moved with a surprising ghostly silence thanks to its electric motors. But the moment it encountered slightly soft or moist earth, the Titan began to sink. It wasn't just getting stuck in the traditional sense. The weight was so concentrated that the tank would displace the soil until it rested on its belly, effectively anchoring itself to the planet. Every test run was a high-stakes gamble with the local geology. Meanwhile, back in Berlin, the political pressure was mounting. Guderian, the Inspector General of Armored Troops and a man who understood tank warfare better than almost anyone, was horrified by the project. He saw the Maus for what it was, a colossal waste of resources. He famously argued that the steel and labor used for one Maus could produce 10 Stoogie 3 assault guns or 5 Panther tanks, vehicles that could actually reach the front lines and maneuver. He pointed out that the Maus would require its own specialized railway car, the Verladewagen, to be moved at all. This 14-axle monster of a rail car was a target that Allied air intelligence would spot instantly. Hitler, however, remained captivated. He began to envision the Maus as a mobile fire brigade that would be stationed at key points along the Atlantic Wall or the Eastern Front. When an enemy breakthrough occurred, the Maus would simply rumble into the gap and become an impenetrable wall. He ignored the fact that at its top speed of barely 13 kilometers per hour and a practical cross-country speed of even less, the gap would likely have moved 50 miles by the time the Maus arrived. It was a weapon designed for a type of static warfare that had ceased to exist in 1918, being built for a war of extreme mobility in 1944. The fatal error was now fully realized in steel. The engineers knew it was a logistical dead end. The generals knew it was a tactical liability. But in the twisted hierarchy of the Third Reich, the momentum of the Führer's obsession carried the project forward. As the V2 prototype, the first with a functional turret and the legendary 128mm gun, began its final assembly, the shadow of the Allied air forces was already falling over German industry. The monster was alive, but the world it was born into had no bridges that could hold it and no roads that could lead it to victory. By the beginning of 1944, the Kummersdorf Proving Grounds became a silent witness to an engineering dead end. The V2 prototype, now fitted with a fully functional turret and the monstrous 128mm gun, was a sight both majestic and absurd. When the Daimler-Benz engine roared to life, the vibrations could be felt for hundreds of meters. However, the moment the tank attempted even a basic maneuver on soft ground, the magic of super heavy superiority evaporated. One of the most insane chapters in the history of the Maus was the attempt to solve the problem of river crossings. Since not a single bridge in Europe could support 188 tons, Ferdinand Porsche's engineers developed a system that sounded logical in theory but was pure madness in practice. The tank was designed to cross water obstacles by driving along the bottom. To achieve this, a complete sealing system and a giant snorkel for air intake were created. However, there was one fatal technical detail. The petrol-electric powertrain required a massive amount of oxygen to run the generator that powered the electric drive motors. The solution? The tanks had to work in pairs. One Maus would remain on the bank, running its engine at full power to transmit electricity via a long cable to the second Maus, which would slowly crawl along the riverbed in total darkness and isolation. If the cable became tangled, snapped, or if the tank struck a large boulder in the silt, extracting this 180-ton steel coffin from the bottom would have been impossible. This turned every crossing into a complex engineering operation that, under real combat conditions and enemy fire, would have been doomed to failure within minutes. Inside the turret of the Maus, the situation was no less catastrophic. Despite its colossal external dimensions, the fighting compartment was overcrowded with machinery. Loading the 128mm gun required incredible physical effort from two loaders. The shells were of a separate loading type and weighed so much that the rate of fire inevitably dropped to negligible levels after the first few shots. Furthermore, the propellant gases from such a powerful weapon instantly filled the cramped turret, and even the advanced ventilation system couldn't keep up with the fumes, causing nausea and dizziness among the crew. But the weakest link in this chain of fatal errors was the transmission. The electric motors, intended to provide smooth movement, suffered from constant overheating. Copper, essential for the windings of the massive generators, was in short supply, and German industry used substitutes that reduced the system's reliability to a critical level. During one test at Kummersdorf, a short circuit in the electrical system caused a fire inside the tank that nearly destroyed the only working prototype. To extinguish the flames in such a cramped space packed with high-voltage equipment, the crew had to perform acts of desperation, risking suffocation from the toxic smoke of burning insulation. While Hitler in his headquarters dreamed of divisions of these monsters, the reality on the fronts was changing with lightning speed. Heinz Guderian, in his reports, explicitly pointed out that the Maus required far too much precious fuel. For every single kilometer of travel, this tank consumed nearly 35 liters of fuel. As the Third Reich began to lose access to oil fields, a single 100-kilometer march by a company of these tanks could have deprived an entire armored corps of Panthers of their fuel supply. Moreover, the Maus was utterly defenseless against Allied air power. With its glacial speed and enormous size, it was the perfect target for Allied ground attack aircraft. The massive surface area of the hull and turret roof made it vulnerable to aerial cannons and bombs. If a lucky hit damaged the track or the suspension, repairs in field conditions were unthinkable. Replacing a single road wheel required lifting the multi-ton hull with specialized jacks, which themselves needed a dedicated truck for transport. In mid-1944, the project was officially mothballed. Resources were desperately needed for the production of Jag Tigers and the reconstruction of bombed factories. But even after the order to stop work was issued, the two existing prototypes remained at the proving grounds as monuments to unachievable ambitions. The end of the mouse story was as ignominious as its concept. Instead of crushing enemy armies, these giants were blown up by their own crews as Soviet troops approached, having never fired a single shot in anger at the enemy. The final act of the Mouse saga took place in the chaotic spring of 1945. As the Red Army closed its iron grip around Berlin, the Kummersdorf testing grounds became a scene of desperate sabotage. The German High Command, realizing that their invincible titans were about to fall into enemy hands, issued a final order: destroy the evidence of their technical hubris. The V2 prototype, the only one with a functional engine and turret, was moved to the headquarters of the Army High Command in Zossen. However, it never saw combat. Just miles from its destination, the mechanical nightmare struck again. The engine suffered a catastrophic failure, and with the Soviet tanks only minutes away, the German crew placed explosive charges inside the hull. The explosion was so powerful that it didn't just disable the tank, it tore the massive 55-ton turret clean off the hull, shifting it several meters. When Soviet scouts of the 53rd Guards Tank Brigade arrived, they didn't find a weapon of war. They found a mountain of scorched, twisted steel that defied all logic. The initial reports sent back to Moscow were met with disbelief. Intelligence officers assumed the descriptions of a nearly 200-ton tank were a product of combat stress or exaggeration. But as more scouts arrived at Kummersdorf and found the abandoned V1 prototype, the scale of the fatal error became undeniable. The Soviet leadership, fascinated by the sheer scale of the German ambition, gave a direct order: the mouse must be brought to the Soviet Union for study. This triggered a logistical operation that was almost as difficult as the design of the tank itself. Since the V2 hull was destroyed and the V1 lacked a turret and engine, Soviet engineers decided to perform a surgical transplant. They would take the intact turret from the wreckage of the V2 and mount it on the functional hull of the V1. The task was a nightmare of heavy lifting. No standard Soviet recovery vehicle or crane could budge the 55-ton turret. Engineers had to use specialized railway jacks and a massive assembly of winches just to slide the turret onto the V1 hull. But the real challenge was the journey. Moving a 188-ton hybrid monster through the ruins of post-war Germany was an odyssey of broken roads and collapsing infrastructure. Every bridge on the route had to be painstakingly reinforced with timber and steel beams or bypassed entirely. In many cases, the mouse had to be winched across fields on specialized metal sleds to prevent it from simply vanishing into the mud. When the Frankenstein-like mouse finally arrived at the Kubinka proving grounds near Moscow, Soviet scientists fell upon it like vultures. They were eager to find the secret weapon that justified such a colossal investment of German resources. They tested the armor with high-velocity shells, analyzed the complex electric transmission, and scrutinized the 128mm gun. But the conclusion of the Soviet report was cold and clinical. The engineers noted that while the armor was thick, the lack of slope on the sides made it vulnerable to modern kinetic penetrators. The electric drive, while innovative, was seen as an unnecessary complication that would be impossible to maintain in the brutal conditions of the Eastern Front. The Soviet experts realized what the German generals had known all along. The mouse was a weapon of a dead era. It was a battleship in a world of submarines and aircraft. It was so heavy that it couldn't be used in an offensive, and so slow that it couldn't be used in a defensive maneuver. By trying to build a tank that was everything, the German designers had created a machine that was effectively nothing. Today, the single surviving Maus stands in the Kubinka Tank Museum, a silent gray tomb of an idea. It remains the heaviest tank ever built, but its true legacy isn't its weight or its cannon. Its legacy is the lesson it taught the world about the limits of engineering. It stands as a warning that in war, industrial logic and logistical reality will always defeat the grandest fantasies of a dictator. The Maus was not a failure of German science, but a failure of German judgment, a 188-ton fatal error that consumed the resources of a nation and gave it nothing in return but a curiosity for a museum. The logistical failure of the Maus wasn't just a result of poor physics, it was the product of a toxic industrial rivalry that poisoned the German war machine from within. To understand why such a resource-heavy mistake was allowed to happen, one must look at the bitter feud between Dr. Ferdinand Porsche and the traditionalist engineers at Henschel and Sohn. This was not a professional disagreement, it was a bureaucratic war for the Führer's favor, where technical logic was often sacrificed for political influence. Porsche was Hitler's favorite. He was seen as a genius creator, an artist of engineering who wasn't bound by the stuffy rules of conventional tank design. This status allowed him to bypass many of the standard military procurement channels. While Henschel was producing the Tiger and the King Tiger, vehicles that were already pushing the limits of reliability, Porsche was whispering in Hitler's ear about electric drives and impenetrable titans. The established Panzer Commission, however, viewed Porsche with extreme suspicion. They saw his petrol-electric hybrid systems as overly complex and vulnerable to the harsh realities of the battlefield. But Porsche had a powerful ally in Albert Speer, the Minister of Armaments, at least initially. This political shield meant that even when the Maus project began to spiral out of control in terms of weight and cost, nobody dared to pull the emergency brake. Every time a general questioned the practicality of a 180-ton tank, Porsche would counter with even more ambitious specifications, playing directly into Hitler's obsession with Wunderwaffen or wonder weapons. The rivalry reached a boiling point during the design of the Krupp turret. Henschel and other manufacturers argued that the resources being poured into Porsche's toy were starving the production lines of the Panther and the Tiger too. There was a constant battle for high-grade steel and, more importantly, for the specialized labor required to build such massive components. The Maus required the most experienced master welders in Germany, men who were desperately needed to repair damaged tanks returning from the Eastern Front. By choosing to build the Maus, the Nazi leadership was effectively choosing to leave dozens of other tanks broken in the mud. Furthermore, the fatal error was fueled by the design-by-committee syndrome. Hitler would frequently intervene in minor technical details. At one point, he insisted that the Maus be armed with a flamethrower. This required the engineers to find space for massive fuel tanks and complex piping inside an already cramped hull. When they finally integrated the flamethrower, Hitler changed his mind, deciding that more ammunition for the 128mm gun was more important. Each of these Führer impulses resulted in months of delays and thousands of wasted man-hours. Even more absurd was the lack of cooperation between the companies involved. Krupp, Porsche, and Alket often operated in silos, guarded by corporate secrecy and political maneuvering. When the massive hull was shipped from Krupp to Alket for final assembly, the engineers discovered that several critical mounting points didn't align. In a rational industry, this would be a minor setback. In the chaotic atmosphere of 1944, with Allied bombs falling on the factories, these minor miscommunications led to catastrophic delays that cost millions of Reichsmarks. This internal warfare meant that the Maus was never truly a unified project. It was a collection of competing egos and industrial interests. While Henschel struggled to simplify the King Tiger for mass production, Porsche was busy perfecting a luxury interior for the Maus cockpit, as if he were designing a high-end limousine rather than a weapon of war. The contrast between the starving soldiers on the front line and the limitless budget of the Maus project was a stark symbol of the Reich's terminal disconnection from reality. In the end, the fatal error of the Maus was as much a political failure as a mechanical one. It was the result of a system where loyalty to a dictator's whim outweighed the cold, hard facts of logistics. The engineers at Henschel, who were often blamed for the delays, knew that the Maus would never change the outcome of the war. They watched in silent frustration as the steel that could have built 1,000 interceptors or hundreds of mobile guns was forged into a single immobile monument to one man's vanity. The madness of the super heavy tank was not a purely German disease. In the mid-1940s, as the war reached its brutal climax, both the United States and Great Britain were secretly developing their own steel monsters. They too were gripped by the fear of impenetrable fortifications and the need for a bunker buster on tracks. However, the American and British approaches to the fatal error revealed a crucial difference in military philosophy and logistical sanity. In the United States, the response to the growing rumors of German heavy armor was the T-28 Super Heavy Tank, later designated the T-95 gun motor carriage. Like the Maus, it was designed to be impervious to enemy fire, featuring a massive 305 mm of front armor. But unlike the Porsche Titan, the American designers were forced to confront a reality that Hitler ignored: the Atlantic Ocean. Every American tank had to be shipped across thousands of miles of water and unloaded at ports that had limited crane capacities. While the Maus was a vertical fortress, the T-28 was a low-slung, turretless slug. To solve the problem of ground pressure, the Americans used 4 sets of tracks instead of 2. Yet, even with this innovation, the T-28 was a logistical nightmare. It weighed 95 tons, barely half of the Maus, and even at that weight, it was considered almost impossible to transport. The American military leadership, unlike Hitler, quickly realized that a tank that couldn't cross a bridge or fit on a standard rail car was a liability, not an asset. Only 2 prototypes were built before the project was quietly sidelined. The Americans chose mobility and mass production over singular massive targets. Meanwhile, the British were working on their own solution, the A-39 Tortoise. Designed to crack the Siegfried Line, the Tortoise weighed 79 tons. It was a massive lumbering assault gun that shared the Maus's fatal flaw. It was too heavy for the standard British transport infrastructure. During trials, the British engineers discovered that moving the Tortoise just a few miles required a massive 24-wheel trailer and a team of specialized recovery vehicles. The British report on the Tortoise was surprisingly similar to the German internal critiques of the Maus. They noted that the tactical advantage of its thick armor was completely negated by the fact that it could be easily outmaneuvered or simply bypassed by enemy infantry. One British officer famously remarked that the tortoise was a great way to get a very large gun to a very specific place, provided that place was right next to a railway station and the weather was perfect. The fundamental difference, however, lay in how these projects were managed. In Washington and London, the super heavies were treated as experimental niche weapons, developed by professional committees who understood the cold math of logistics. In Berlin, the Maus was a centerpiece of national strategy, fueled by the whims of a dictator who believed that willpower could overcome the limits of steel and soil. While Porsche was adding more weight to the Maus, the Allies were perfecting the Mulberry artificial harbors and the logistics of the D-Day landings. They realized that winning a modern war required moving thousands of 30-ton Shermans, not a handful of 180-ton giants. The existence of the T-28 and the Tortoise proves that the engineering urge to build the biggest was universal, but the decision to actually put the Maus into production remains the definitive fatal error of German industrial planning. It was a symptom of a regime that had lost the ability to distinguish between a terrifying weapon and a useless monument. As we look at these three machines together, the Maus stands out not as a pinnacle of design, but as an outlier of delusion. The American T-28 and the British Tortoise survived as historical footnotes, tucked away in museums as what-if scenarios. But the Maus was forced into the reality of 1945, where its massive weight became its own executioner. It was a machine built for a war that only existed in Hitler's imagination, a war where the enemy would politely wait for a 13-kilometer-per-hour Titan to crawl toward them across a landscape that had no bridges left to hold it. To truly understand the depth of this fatal error, we must step away from the blueprints and into the mud of a hypothetical 1945 battlefield. Imagine for a moment that the logistical nightmare had been overcome. Imagine a platoon of 3 Panzer VIII Maus tanks has managed to reach the front lines during the Soviet Vistula-Oder offensive. On paper, they are gods of war. In reality, they are about to experience a tactical slaughter. The first thing that would betray the Maus was its sound and its signature. Long before the Soviet tankers saw the gray mass of the Porsche Titan, they would feel the earth tremble. The acoustic signature of a 1,200 horsepower aircraft engine straining to move 188 tons would be detectable for miles. In the fluid, fast-paced environment of 1945, where the Red Army utilized massive flanking maneuvers, the Maus would be a static landmark in a moving war. As the Maus crawled forward at its pathetic tactical speed of 7 or 8 kilometers per hour, it would immediately encounter the artillery trap. Soviet doctrine at the end of the war relied on massive concentrations of 152 mm and 203 mm howitzers. While the 220 mm front armor of the Maus might resist a direct hit from a tank gun, it was never designed to survive a sustained barrage of heavy high-explosive shells. A 152 mm shell wouldn't need to pierce the armor. The sheer kinetic energy and blast wave would shatter the internal optics, snap the complex suspension torsion bars, and leave the crew concussed and bleeding from the ears inside their impenetrable fortress. Even if the Maus survived the artillery, it would face the nightmare of Soviet infantry tank killer teams. In the ruins of a German village or the dense forests of the East, the Maus was a blind giant. Its turret traversed so slowly that a nimble T-3485 or a group of soldiers with Panzerfausts or captured anti-tank grenades could easily get into its dead zone. The Maus had a massive shadow, an area around the tank where its guns simply could not depress low enough to hit a target. Soviet infantrymen would crawl under the overhang of the massive tracks, placing satchel charges directly onto the thin belly armor or jamming the drive sprockets with metal rails. Then there is the sky. By 1945, the Luftwaffe had evaporated, leaving the German panzers at the mercy of the Black Death, the EL-2 Sturmovik. For a Soviet pilot, a Maus was the ultimate prize. It was too big to miss and too slow to dodge. A single 132mm RS-132 rocket or a 100-kilogram bomb dropped onto the thin 60mm roof armor would end the legend of the Maus in a fireball. The very size that was meant to intimidate the enemy became its greatest vulnerability. It was a target so large it had its own zip code. But perhaps the most ignominious end for our hypothetical Maus wouldn't come from a shell or a bomb. It would come from the ground itself. The moment the driver attempted to steer the Titan off a paved road to avoid a roadblock, the war would be over. The 188-ton weight would exert such pressure that the tank would dig its own grave in the soft spring soil of Poland or Germany. Once the hull bottomed out, resting its weight on the belly plates, the tracks would spin uselessly in the air. At this point, the crew would face a harrowing choice: stay inside their steel tomb and wait for the Soviet heavy IS-2 tanks to surround them and use them for target practice, or abandon the most expensive weapon in the German arsenal and run. In every realistic combat simulation, the Maus doesn't end the war, it ends itself. It is a weapon that requires a perfect laboratory-clean environment to function, an environment that never exists in the chaos of a collapsing empire. The fatal error was believing that armor thickness could substitute for tactical flexibility. The Maus was designed for a duel that the Allies refused to fight. They wouldn't stand in front of it and trade shots. They would go around it, fly over it, and bury it under a mountain of high explosives. The Titan was not a wolf among sheep. It was a stranded whale on a beach waiting for the inevitable. The true cost of the Maus was not measured in Reichsmarks alone, but in the staggering amount of strategic materials it diverted from a nation that was literally starving for resources. By 1944, the German war machine was a hollow shell, struggling to produce enough basic ammunition and fuel to keep its remaining divisions functional. Into this desperate environment, the Maus arrived like a parasitic twin, consuming everything in its path. The most critical, fatal error in the resource management of the Maus was the use of copper. Porsche's insistence on a petrol-electric drive meant that each tank required massive electrical generators and two enormous propulsion motors. These components were packed with high-grade copper, a material so scarce in late-war Germany that the government was stripping copper wiring from civilian houses and bells from churches. It is estimated that the copper used in a single Maus could have provided the electrical components for over 50 Stooge 3 assault guns or dozens of Focke-Wulf 190 fighters. Then there was the fuel, the lifeblood of any mechanized army. The Maus was a glutton. Its 1,200 horsepower engine was constantly working at peak capacity just to overcome the immense friction of its own tracks and the inertia of its weight. In cross-country movement, the fuel consumption was so high that a single company of Maus tanks would have required a dedicated train of fuel tankers just to follow them from one sector to another. For a Germany that was losing its last oil fields in Romania and Hungary, the Maus was a strategic liability. To fuel one mouse for a single day of combat operations, the Wehrmacht had to deprive an entire battalion of Panther tanks of their ability to move. It was a trade-off that made zero sense to the logistics officers at the OKH, yet they were forced to comply with the Führer's whim. The production of the armor plate was another industrial nightmare. Krupp had to utilize its largest naval steel presses, machines normally reserved for the armor of battleships like the Tirpitz, to forge the 200 mm thick plates for the mouse. The heat treatment process for steel of this thickness took weeks. If a factory was bombed mid-process, the entire batch was ruined. The labor hours required to assemble one mouse were astronomical. While the Soviet Union was perfecting the T-34, which could be assembled in a matter of days by unskilled workers, the mouse required thousands of hours from Germany's most elite master craftsmen, welders, and engineers. This diversion of brain power was perhaps the most hidden cost. The same engineers who were trying to figure out how to keep a 188-ton tank from sinking into the mud were the minds that could have been perfecting jet engines, refined radar systems, or more reliable transmissions for the existing Panther tanks. The Mouse project acted as a vacuum, sucking the best talent away from projects that actually had a chance of changing the war's outcome. Even the ammunition for the 128mm main gun represented a logistical burden. These shells were so heavy and large that they couldn't be moved in standard ammunition crates. They required specialized handling equipment and took up massive amounts of space in the transport chain. A single supply truck that could carry hundreds of 75mm shells for a Panzer IV could only carry a handful of rounds for the Mouse. When you add up the copper, the high-grade steel, the thousands of liters of synthetic fuel, and the elite man-hours, the fatal error becomes clear. The Mouse didn't just fail as a tank, it succeeded as a weapon of economic sabotage against its own creators. It was a monument to industrial vanity that helped bankrupt the very empire it was meant to save. As the prototypes sat at the Kummersdorf range, they were essentially made of the blood of the German army, the fuel they didn't have, the planes they couldn't build, and the tanks they couldn't repair. The project was a perfect example of gigantomania, a psychological state where the scale of a project becomes more important than its utility. In Hitler's mind, the Mouse was a masterpiece because it was big. In the mind of a logistics officer, it was a tragedy because it was a drain. In the end, the logic of the logistics officer proved correct. You cannot win a war with a few giants if you've starved your entire army to build them. Although the Mouse never fired a shot in battle, its ghost haunted the design bureaus of the Cold War for years. The sheer existence of a 188-ton tank created a ripple effect of paranoia among Soviet, American, and British engineers. They looked at the wreckage in Kubinka and Zossen and asked themselves a dangerous question. If the Germans almost did it, can we do it better? This led to a brief but intense revival of the fatal error during the late 1940s and 50s. The Soviet Union was the first to fall under the spell of the super heavy ghost. Having captured the Mouse, Soviet designers at the Kirov plant began working on the IS-7. It was an attempt to create a practical Mouse, a 68-ton monster with 130mm naval guns and armor that could shrug off almost anything. While the IS-7 was a masterpiece of engineering compared to the Mouse, it suffered from the same logistical curse. It was too heavy for Soviet bridges, and its specialized double planetary transmission was a nightmare to maintain. The Soviet leadership eventually realized that 10 T-54s were worth more than one IS-7, and the project was scrapped. Across the ocean, the United States was also chasing the dream of the heavy breakthrough tank. The M103 heavy tank and the British Conqueror were born from the same fear that had fueled the Mouse: the need to destroy any target at extreme range with heavy armor protection. These tanks weighed over 60 tons and were equipped with massive 120 mm guns. Yet, like the Mouse, they were plagued by mechanical failures and logistical limitations. They were so heavy that they often had to be transported by rail to the very edge of the battlefield because their tracks and engines couldn't survive a long road march. The most extreme example of this post-war Mouse think was the Soviet Object 279, a tank designed to survive a nuclear blast. With its 4 sets of tracks and saucer-like hull, it looked like a UFO on treads. It was an incredible technical achievement, but it was the final nail in the coffin for the super-heavy concept. Engineers finally had to admit that as anti-tank guided missiles and high-velocity kinetic penetrators advanced, no amount of steel armor could guarantee invincibility. The race for thickness was officially lost to the race for physics. By the 1960s, the world moved toward the main battle tank, or MBT. This was the ultimate admission that the Mouse had been a mistake. The MBT, like the T-62, the M60, and later the Leopard 1, prioritized a balance of firepower, mobility, and reasonable weight. The lesson learned from the 188-ton German failure was that a tank's best defense wasn't just its armor, but its ability to move, hide, and be transported easily to wherever the war was happening. The Mouse had been a fatal error because it ignored the fundamental law of military evolution. An organism that grows too large for its environment is doomed to extinction. The environment of modern war is fast, fluid, and lethal. A dinosaur like the Mouse, no matter how thick its hide, had no place in an era of jet engines and hollow charge warheads. As military historians look back at the Cold War, they see the Mouse as a bridge between two eras. It was the last gasp of the fortress tank philosophy and the starting point for the realization that logistics must dictate design, not the other way around. The giants of Kubinka and the forgotten blueprints of the T-28 and Tortoise serve as a collective memory of a time when humanity thought it could win wars by simply building something bigger than the horizon. Today, when we see a modern Abrams or T-90 crossing a bridge at 60 kilometers per hour, we are seeing the direct antithesis of the Mouse. We are seeing machines that learned from the 188-ton mistake. They are lethal, but they are also practical. They fit on trains, they cross bridges, and they can be repaired in the field. The Mouse remains a singular, bizarre anomaly, a giant that stood still while the rest of the world learned how to run. The Panzer VIII Mouse remains the ultimate symbol of a regime that had replaced reality with a fever dream. It was a machine that existed only because the checks and balances of a sane military-industrial complex had been dismantled in favor of a cult of personality. In a rational world, the Mouse would have never made it past the wooden mock-up stage. But in the hollowed-out institutions of the Third Reich, it became a runaway train of resources and effort, a monument to the dangerous idea that sheer mass can substitute for strategic wisdom. When we look back at the history of warfare, we see that the greatest commanders were not those with the biggest weapons, but those who understood the boring science of logistics. Napoleon famously said that an army marches on its stomach, and in the 20th century, That stomach was filled with fuel, spare parts, and ammunition. The mouse was a creature that could never be fed. It was a tactical dead weight that required more from the army than it could ever give back. Its fatal error was not a single mechanical failure, but the fundamental rejection of the most basic rule of war. If you cannot move it to the fight, it is not a weapon, it is an obstacle. The destruction of the mouse prototypes by their own crews in 1945 was the only logical end to their story. These tanks, which were supposed to be the hunters, died as stationary targets, unable to flee, unable to fight, and unable to find a bridge that would carry them to safety. They were sabotaged not by enemy fire, but by their own weight and the collapse of the infrastructure they had helped to bankrupt. The explosions that tore through their hulls were the final punctuation mark on a sentence of industrial madness that had begun 3 years earlier in Porsche's design office. For the modern viewer, the mouse serves as a fascinating lens through which to view the end of the Second World War. It reveals a Germany that had lost its way, a nation that, instead of focusing on the mass production of reliable aircraft and versatile tanks, chose to chase a phantom of invincibility. It shows a leadership that preferred the spectacle of a 188-ton giant over the substance of a functional logistics chain. It is a warning that when a military's equipment becomes more important than its ability to deploy it, that military has already lost the war. As the sun sets over the Kubinka Tank Museum today, the gray silhouette of the last mouse casts a long shadow over the history of armored warfare. It stands as a silent witness to the peak of Gigantomania. It is a machine that inspires awe because of its size, but also pity because of its futility. It is the physical manifestation of a fatal error, a reminder that in the grand theater of history, brilliance without practicality is merely a tragedy in the making. The story of the mouse is not just about a tank, it is about the arrogance of power and the limits of engineering. It is a story that teaches us that true strength is